Hello everyone, my name is Lokman bin Muhammad Nasir from CDCS1103C. I am from the group ISZ, which consists of three members, me, Muhammad Iqbal Mukri bin Amran, and Muhammad Syamil Akram Nozamri. The topic of this video is logical implications and logical equivalence. Before we head into the topic, I will be telling you firsthand what will be in this video. First off,
This is our group members. Our group consists of three people. Me, Muhammad Shamik Akram Zamri, with student ID 2023620588. Muhammad Iqbal Mukri bin Amran, with student ID 2023474496. And Zaran Lokman bin Muhammad Nasir, with student ID 20238383 and 86.
First off, I will be explaining about the basis of the fundamental of logic. The baton will then be passed to my friend, in which they will explain to you about the logical equivalence, converse, inverse, contrapositive, and logically implies. After that, the three of us will be answering three questions related to the topic, and we will end the video with the summary. Now, let's head into the topic. First off, what is logic? Logic is the study of reasoning and principles of valid arguments in which purpose is to distinguish correct reasoning from flawed reasoning. It's basically a way for you to derive conclusions from premises using structured and consistent method. Thus, fundamental of logic is the core principle and concept of reasoning and critical thinking. There are four core elements of fundamental of logic. There are statements, arguments, inference, and connective. There are five connective, and each one is represented by a symbol, and is represented by the symbol often V, or is represented by V and not represented by the worm symbol. These connective are used inside the premises, and then we have if then represented by one way arrow, and if and only if represented by double-sided arrow, which are basically the rule of premises for us to derive a conclusion from. Now, what is statement? Statements are statements that are either true or false. There are two kinds, which is simple statement and compound statement. Simple statement is a statement of one that can be assigned true or false value. For example, Fadil likes to play volleyball. And then we have compound statements, which are two or more statements combined and can be assigned true or false value. For example, if I win this match, then I will continue playing. Argument is a group of statements that include one or more premises and one conclusion. The usage of argument is intended to support or provide evidence for the conclusion. Lastly, we have inference, which is the process of deriving conclusion from the premises.
So here we have tautology, which is a statement that are always true, and contradiction is a statement that are always false. For contingency, it is a statement that are neither tautology or contradiction. So here, this means that the statement is not actually true or false. It's in between. Not in between, it's neither of them. So logical equivalent. When two compound statements R and S is said to be logically equivalent, it will be written as R, the symbol, logically equivalent to S when the statement R is true or false if and only if statement S is true or false. Alternatively, when two compound statements P and Q are said to be logically equivalent, it will be written as P logically equivalent to Q if Q is a tautology. So here we have an example of a truth table. As we have only two variables, which is P and Q, so for P we put the first two columns as true and the last two columns as false. For Q, we put it true, false, true, false. And when not P, we just negate P, and if the value from P is true, the negative is false. Because you see the first two columns became false and the last two columns became true. So when P implies Q, both of the value need to become true for it to become true. But if the second value is false, then it will become false. But if the first value is false, then it will automatically become true. And for not P or Q, it depends on the false. So if the both of the statement is true, then it will become true. But if one of the statement is false, then it will become false. And by here, we can see that P implies Q and not P or Q have both have the same truth value. Yeah, both have the same truth value. So therefore, P implies Q logically implies not P or Q. Converse, inverse, and contrapositive. Converse, we swap the position between the hypothesis and the conclusion. So if it's actually P implies Q, it becomes Q implies P. For inverse, we negate both the hypothesis and the conclusion. So if the hypothesis is P implies Q, it becomes not P implies not Q. So for contrapositive, we negate both hypothesis and the conclusion in the converse statement. So if the converse statement is Q implies P, it becomes not Q implies not P. So here we have a simple conditional statement. First, if Fyodor write a book, then he will become famous. Converse to the conditional statement, if Fyodor become famous, then he wrote a book. And inverse statement, if Fyodor does not write a book, then he will not become famous. Contrapositive to the converse statement, if Fyodor does not become famous, then he did not write a book.
Logical implication. So what is logical implication? If P implies Q is a tautology, then P logically implies Q. Example, statement P, the phone battery is charged. Statement Q, the phone can be used. Logical implication. If the phone battery is charged P, then the phone can be used Q. If the phone battery is charged, we can logically conclude that the phone can be used. So here we have some example. Question 1. Determine if the following statement is true. Q and not R, or Q and Q implies P logically implies P and Q. So how do we solve it? First, we create a truth table and put all the possible value for P, Q, and R. For table P, the value is TT, TT, FF, and FF. For table Q, TT, FF, TT, and FF. For table R, TF, 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 and TF. Next, we negate the R and look at the R table and you get all the value. And the output value is FT, 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 and FT. Next, we will solve the first part, which is Q and not R, and name it as A. And the value is FT, FF, FT, and FF. After that, we will solve the second part, which is A or Q, and name it as B. And the value is TT, FF, TT, and FF. Next, we will solve Q implies P and name it as C. And your output value is TT, TT, FF, and TT. Next, we will solve B and C and name it as D. And the output value is TT, FF, FF, and FF. Then we will solve P and Q and name it as E. And the output value is TT, FF, FF, and FF. And lastly, we will solve D implies E and look at table D and E. So the output value is TT, 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 and TT. So all the output value is true. Since the last column is a tautology, therefore Q and not R or Q and Q implies P logically implies P and Q.
So now we go to the second question. Determine if the following statement is true. P and Q implies R logically implies P implies R or Q implies R. So here we have a truth table. For P, we put the first four columns as true and the last four columns as false. For Q, we put the first two columns as true and the next two subsequent columns as false. And the next is two true and two false. For R, we put a true false for each of the column. For P and Q, both of the value needs to become true for it to become true. If one of them is false, they will become false. For P and Q implies R, both of the statements need to be true for it to be true. But if one of the statement is false, let's say the second statement is false, then it will become false. But if the first statement is false, then it will automatically become true. Same goes to P implies R and Q implies R. Next we have P implies R or Q implies R. We can see that both of the statements need to become true for it to become true. If one of the statement is false, then it will become false. It depends on the false statement for it to become false. So as we can see, both of the column truth value is the same. Therefore, P and Q implies R. P and Q implies R is logically implicate P implies R or Q implies R.
And so we head to the third question. The statement is as follows. If Iqbal manages his time well, then he can submit the assignment on time. If Iqbal submits the assignment on time, then his submission is valid. Iqbal's submission is valid. Therefore, Iqbal manages his time well. First, let's identify the key idea in this argument, which we call the primitive statements. These are P, Iqbal manages his time well, Q, Iqbal submits the assignment on time, and R, Iqbal's submission is valid. And so, we will write down the premises and conclusion, which is premise 1. If P, then Q. If Iqbal manages time well, then he submits the assignment on time. And then we have premise 2. If Q, then R. If Iqbal submits the assignment on time, his submission is valid. And then finally, we have premise 3, which is R is true. Iqbal's submission is valid. The conclusion we need to prove is P is true. Iqbal manages time well. Now, let's prove this step by step using logical rules of inference. From premise 3, we know R is true, but submission is valid. Using premise 2, if Q, then R, and R. We apply correspondence. That means that if Q, then R, and R is true, then Q must also be true. So Q is true. Iqbal submitted the assignment on time. Using premise 1, if P, then Q, and Q. We again apply correspondence. If P, then Q, and Q is true, then P must also be true. Therefore, P is true, and the argument is valid.
Now for the summary part. In summary, logic provides the foundation for reasoning and proving mathematical theorems, serving as a critical framework for constructing arguments and verifying their validity. Logical connective, such as and, or, and not, as well as logical equivalence, provide the tools to combine and simplify complex statements into coherent arguments. These principles are indispensable not only in pure mathematics, but also in practical fields such as computer science, artificial intelligence, and data analysis.